Okay, here we go, guys. All right, so they gave me my rate of 2.81, and they also told me that we're going to use A0 of 6.01. So we're going to use the explicit formula that uses the A0 term, and we're going to replace our pieces. My rate gets changed to 2.81, and our A0 got changed to the 6.01. And this is our formula, the end. Okay? Now we're going to go the other way. So now I'm giving you the explicit, I want the recursive. So they've given me two pieces of information here. What is 98? That is is it A1 or is it A0? Look at your exponent. Look at your exponent. It's going to be A0. Exactly. If it was A1, you'd have N minus 1. Good. And what is the 4.41? That is my ratio. So they have given me my ratio and my A1 value. What do I need for my recursive formula? I just need my ratio. So all I got to do is replace this R with 4.41, and there's our recursive formula. So recursive does not use the first term. So the skill we're trying to show here is, can I rewrite it by knowing what information I need and knowing what information was given to me? Questions for me right now? Okay. You and your table people, please work on the next one. You have been given the recursive formula and you've been given A1. I want you to write the explicit formula for this sequence. Explicit, yeah, so either A1 or A0 is what you're using. All right, so something was pointed out. Does it matter that negative 1.35 is now in front of my previous term instead of being multiplied after my previous term? Yes. It does not matter. Does order matter with multiplying? Is 3 times 2 the same as 2 times 3? Yes. So it's okay that my rate was written in front of my previous term. Okay? So my rate is negative 1.35. My A1 is 2.4. That's what they gave me. What do I need for the explicit formula? I need both of these pieces. Good. And because we have A1, we're going to use that N minus 1. Yep. Exponent. So yeah, we're going to use R to replace this piece, and then our 2.4 should replace our A1 value, and this is what we should get. How'd you do? Did you do okay? Yes? We got one more converting. I got it. I helped him out though. Good. One more converting. This time, you and your table people, I've given you the explicit formula of 12 times 1.119 raised to the power of n, and I want you to write the recursive formula for this sequence. Ready, go. All right, check your answer with mine. So they gave me ratio, and they gave me a sub-zero, but the only thing you need for recursive is the ratio. So that's the only value we need to plug in. My previous term times 1.119. All right, so how do we feel about converting back and forth? Feel okay? Yes? Okay, so in your homework, this will help you with 1 through 4 in your homework. Okay? Number 5 on your homework is a little throwback from yesterday. Yep. Number 6 on your homework, you're comparing Libby and Liz, I believe, to see who did the problem correct. Okay? Was it Libby? Was it Liz? Was it both? Was it none? Okay? And then tell me why. Now, to help you with number 7, that's going to be our final 2 examples in our notes. Because now we're bringing variables in. We're bringing variables back. What? Okay. The multiple choice problem on your notes, we are not doing that. The one with the radicals, we are not doing that problem. Okay? We're moving on to this one. If you were trying, the answer is B. If you were trying to do that problem. But we are not going to do it. We're going to go here. Okay. So what is the common ratio of the sequence? So we've done this before without variables. Okay. To find a common ratio, we pick a piece of my sequence and we divide it by the piece before it. Okay. Yes, we're still going to do the keep, change, flip. It's still happening because we still have fractions that we're working with. Because technically, would you agree that all these variables are fractions? They're just over 1. Okay, so I'm going to pick a term. I'm going to do negative 3 over 28. Okay, I'm going to put x to the 5th and y to the 6th in the numerator with it. We're going to divide that by the previous term, which was 1, x7, y to the 5th, over 56. Because you have to take a piece and divide it by the piece before. That's how you figure out what did I multiply by to get there. We're doing the inverse of it. Okay. So now we do our keep, change, flip. So from here, we're going to keep my first term. So negative 3, x to the 5th, y 6 over 28. Oops, sorry. And now I'm going to change it to multiplying. And we're going to flip my second term to be 56 over x to the 7th, y to the 5th. It can be there. It doesn't have to be there. It's totally up to you. So keep, change, flip is how we divide fractions. Multiplying fractions, we just go straight across the top, straight across the bottom. Okay, so in my numerator, let's go straight across the top and do like terms. So negative 3 times 56 gives me good. Negative 168. I still have x to the 5th power, and we still have y to the 6th power. Oh my goodness. No, my wrist keeps tapping it. My denominator, 28 times 1 is 28. Then I still have x to the 7th, and I still have y to the 5th down here. So now, throwback Friday, law of exponents, still a thing that's still going to happen. Okay, so we're going to simplify each piece, and we're going to take it one piece at a time. Okay, so let's do my coefficients first. Negative 168 divided by 28. What does that give me? Negative 6. Good. Now let's just look at my x's. X to the 5th over x to the 7th. What do I do with my exponents? We're going to subtract them. Good. So what is 5 minus 7? Negative 2. So where is x squared going to go? On the bottom. Good. That you can't see that. No one can see that. That is not a good color. There we go. Because x to the 5th over x to the 7th. I did 5 minus 7, which gave me negative 2. A negative exponent means it falls down to the other spot, like that. Okay. That's one way to show it. The other way I can show it to you is I can actually write it out. Remember, x to the 5th means I have 3, 4, 5 x's up top. 3, 4, 5, 6, and 7 x's on the bottom. So when I start canceling out common pieces, whoop, I missed one. There. There we go. I have 2 left on the bottom. That's another way to show it. Okay? All right. Now my y's. Yes, sir.
Why isn't y showing the answer?
I'm not done yet. I haven't gotten there. I was still explaining the x's. All right, now I have y to the 6th over y to the 5th. What do I do with my exponents? Subtract them. So what is 6 minus 5? 1. So is y to the 1 going to go top or bottom? Top. And that is my common ratio. Negative 6y over x squared. So this is tying in law of exponents for you. Yes, sir.
How did you get rid of the mustard seed?
I divided. Fractions is dividing.
Oh, yeah, that's how
So I actually did that math operation.
They used to be really difficult with
Okay.
fractions. I thought they were something. I was like, oh, you can just divide them.
Okay, if it was asking me, is this the geometric sequence, I would have to do this again to prove it happened again, but that's not what these directions tell me. They say, what's the common ratio? So I already know it's a common ratio. I don't have to do it again. One time I found it, we're done. Okay.
It's all math. This is pattern.
All right, last one. And this guy is going to help you with the last problem on your homework today. So what is the 12th term of a sequence defined by a1 equals 2x to the 4th and an equals 3x over y times a to the n minus 1. All right, so we need to find the 12th term, right? Our goal here is to find a sub 12. They gave me a1, right? So I need to use our explicit formula that uses a1 because they gave me a1. So that's what I'm going to use. Have I lost anybody yet? Okay. Do you know why I wrote that formula?
They give you A1 and they give
Because
you
they gave me a1. Yes. They gave me a1 right here.
and if they gave you A1.
Do we understand how I wrote the formula? That is the question. Okay. Okay, because they gave me a1, that's why I'm using the a1 formula. So, I know a1 is what? 2xy to the 4th? Do we know my ratio? What is my ratio? 3x over y. Raised to the n minus 1, and I know what my n is. My n is 12. Yep. So that's the setup part. Are we go with the setup? That's not mine, it's next door. Yes. All right. So now it's time to use law of exponent skills. So 2xy to the 4th just stays 2xy to the 4th. I am going to put it over 1. Since my ratio is a fraction, I'm going to have to multiply by a fraction. So let's go ahead and put it over 1. Since 3xy is being raised to the power of 12 minus 1, which is what number? 11. I'm going to give every piece inside the exponent of 11. Okay, 2xy to the 4th over 1 times. All right, all I'm doing in this next step is I'm actually going to do 3 to the 11th power. Okay, so 3 times itself 11 times, which is why I offered. Yeah, so we're taking this, and it's 177,147. So that's all I did in that step. Everything else is the same. Okay, so I plugged in what I had. Law of exponents, I have distributed my exponent of 11 to each piece of that fraction, since it was all being raised to that same exponent. All I've done next is simplified 3 to the 11th power. Now I have a fraction times a fraction. So now I'm just going to multiply straight across the top and straight across the bottom. So across the top, what is 2 times the 177,147? Or it's 354,294. All right, I have 2 x's. Do you agree? In my numerator, I have this guy and I have this guy. So what is x times x to the 11th? X to the 12th. Good. Yep, technically there's a 1 right here. So I had 1 x on that side. I had 11 x's on the other side. So together, I have 12 x's in my numerator. All right, in my denominator, just 11? Y to the 11th. Good, be careful. Do I have another y? What is it? I have y to the 4th. Don't lose it. So I got one final step to do. Because I have my 2 y's. I just need one. So what am I going to do with y4 and y11? Subtract them. What is 4 minus 11? -7. So is it going to go in my numerator or is it going to go in my denominator? It will be in my denominator. Very good. And this is our 12th term. It happens with this. With the sequences, we do get big numbers. It's happened a lot up till now. So hopefully that's not too scary. When you get a big number, it is going to happen. All right. So this one's going to help you with the very last question. That's fine. Okay. Any questions about this one before I let you just work? We're okay? Okay.